So today we're going to hit chapter 20. It's our last chapter. On Thursday, we're going to talk about the final exam. And you already know the dates for the final exam. So today we're going to talk about this topic. And it's kind of one that we'll cover here in 161. You'll use a little bit in 162. So you need to know it going in. And some of you will actually see it again in 230 because I have students who go from 121 right to 230. And I think recursion is one of those topics that you kind of need to cover. So again, this is called recursion. Recursion. And we're going to start out with something that's called a recursive function. Oh boy, going back to algebra, it's an example with a math. Now, in order to do a recursive function, this looks a little bit like a piecewise function. And in my world, I think we teach piecewise functions wrong. We do it straight algebraically and not real world. You know, I would rather see us have data. And if we start collecting data and I make, what do you say that is? You know, for these first whatever numbers, you know, that sure looks like a line. But what happens after that, it looks like we get some sort of a quadratic equation. And then maybe then, you know, my data is going to, so now all of a sudden I have a piece of a function that goes like that, piece of a function that goes like that, and a piece of a function that goes like that. So then we start coming up with equations to fit all those. But anyhow, that's just my opinion. So this looks like one of those piecewise functions where the function, I'm going to base it on the value of x. And in this first case, I'm going to say, let's let x equal 8. Now, which of these three equations will I use to go with this function? Will I use this first expression to make my equation, second or third? So it's going to be based on, yeah, the third. It's going to be based on what the domain value is. In this case, the domain value is 8. So I'm going to use the third. So now if I start to try to figure this out, f of 8 is going to be the same as f of 7 plus 6. Now, this is the idea behind recursion. I keep doing the same things over and over with the same type of code, but usually simpler. And as I'm doing these, I have cases that recall my recursion. These are called my recursive cases. And then, of course, I have one case here that's the base case. And that's the one that makes everything stop and I don't keep calling something recursive. So I'm going to keep going here. In order to find f of 8, I need to find whatever f of 7 is and add 6 to it. So I'm going to say, okay, here's f of 7. F of 7 is going to, that's going to be f of 6 plus 6. Now I have to find this f of 6. Well, in order to find f of 6, still using this, I know that it's going to be f of 5 plus 6. Oh boy. I need to find f of 5. This time my domain value still is here. F of 4 plus 6. Now I need f of 4. Things start to change for me. F of 4 falls in this range. In order to find f of 4, it's going to become 2 times f of 3 plus 3. Okay. Now, in order to do this, so I keep recursively going down and down and down. I need to find f of 3. F of 3 is going to be 2 times, in this case, f of 2 plus 3. 2 times, I don't know what that is yet, plus 3. Finally, I say, uh-oh, I need f of 2, and f of 2 is going to make me happy because that's going to fall in this base case that doesn't call anything recursively, and f of 2 now gets the value of, say, 5. Anybody? Type it in the chat somewhere. 5. Five, thank you. Now that I know f of 2, what does f of 3 become? You can use your calculators. Actually, you can use your
And,
fingers. 10,
and,
what is it?
and
Plus 3?
oh, it's 2 times. It looks
Yeah,
like
two
plus, sorry.
times. I'm sorry. Yeah, 2 times.
That's
13.
13.
Keep working my way back. 2 times 13 plus 3. I'll help you on that one. 29. Work my way back. Now that I know what f of 4 is, I replace that and get 35. Now that I know what f of 5 is, I replace that and I get 41. Now that I know what f of 6 is, I replace that and get 47. And now that I know what f of 7 is, I replace that and I get the answer that I wanted, 53. So with our fingers crossed, we're going to hope that it's 53. All right, so that's an example with a function of recursion. For the code listings, you typed in a bunch of little mini programs that hopefully now start to make a little bit of sense. Recursion, recursive function, is one that calls itself. We called it F, not the best name. The code listing showed you some other ones that actually called themselves. Let's take a look at some of these as we go through while I'm talking. In 20.1, I have a recursive function. My function is called message. I bring a number in. I come down here. If it's greater than 0, then I keep going. I call message again. It's another example in 20.2 of one called message you typed in. And again, a recursive function is one that can be solved as long as you can break it down and make it smaller, but that's identical. There's lots of variations on recursion. If you wanted to really get into it, you could actually have 2 recursive functions, one that jumps to the other, that jumps back, and we could go back and forth between them. Okay. Now, do we need recursion? The answer to that question is no. Everything you can do recursively, you could actually do with a loop. Sometimes a loop is more confusing to work with. Sometimes recursion is less efficient to work with. It's better off to do a loop. But anything that you can do with recursion, you can do with a loop. Another example. Here we go again. Code listing 20-3. I have a function called factorial. If I come in, say, with the number 4, if it equals 0, return 1. It doesn't. Otherwise, it becomes 4 times factorial 3. So it becomes 4 times something. So then it becomes 3 times something. Then it becomes 2 times something. Then it's 1. So the 1 returns. 2 times 1 is 2. It returns. 3 times 2 is 6. It returns. 4 times 6 is 24. So it's nice and clean here of what to do. Now, could I do that with the loop? For counter equals 1 to 4. Total equals total times counter, and you just keep going through and multiply away. But recursion is a concept that's good to understand. And when you take 162, you're going to see better examples of why the recursion works. As I mentioned a little while ago, we have our recursive cases that reduces it because we're usually going to be subtracting from one of our parameters when we recall it again. Okay. And then the base case is the one that usually doesn't have a recursive function in it. So now if I jump to code listing 20-4, it's another one that you typed in. And this one's kind of neat. It goes through and talks about the characters in a string. Okay, so display the number of times the letter D appears. And it's a way to traverse through one at a time, checking to see if it equals a D. So I start with the first, and it keeps going all the way to the end. And of course, you're probably thinking there are other ways to do this. GCD. greatest common divisor, greatest common factor. It's called that as well. There is a Euclidean method, which is what this uses to come up with the greatest common factor. Now, let's see, I see enter two integers, 49 and 28. So if I'm going to enter 49 and 28, where's that other piece of paper at? It's here. If I enter 49 and 28, and I say GCD 49 and 28, what happens here? What's going on? How does this work? Or did you just type it in and you were happy with it? GCD 49, 28. Well, it's just tiny code. The code is if X mod Y is equal to 0, then I return Y, else I make my recursive call, and I'm gonna, you notice how I'm doing a return again, because I'm sending a value back. Return GCD of, okay, Y, comma, X mod Y. All right, so y'all are pretty smart. Let's see how this works. I call GCD of 49 and 28. Right now, my X is 49. My Y is 28. My question is, does X mod Y equal 0?
No.
No, it doesn't. So now I'm going to call it again. This time, I'm going to rearrange things. I'm going to return the value of 28 will now go where? So Y is 28.
The X.
Yeah, so 28 goes here. What goes here? X mod Y. What do we get?
21.
21. X mod Y. 21. Does X mod Y evenly?
Nope.
Nope. So I'm going to do it again. This time Y gets a value of 21. Whoops, excuse me. X gets a value of 21. Y gets a value of X mod Y, which is what? Divide 21 into 28,
So-
one time, remainder of 7. Okay, let's check it again, because I'm calling it this time with 21 and 7. If I put in 21 mod 7, does it equal 0? 7 goes into 21
Yes.
3 times with the remainder of? Say 0.
3 times.
0.
0. So I'll return Y, and Y is my GCD. Is that the greatest common denominator for 49 and 28?
Yes.
Yes. I think I have very little help here. We will try this again. I need two numbers. 148. Somebody give me another number. 68. When I do the GCD, remember what I want. Does 68 go into 148? Say no.
No.
Nope. So this is 68. This becomes the remainder. 148 divided by 68. What's the remainder?
40.
If I
40.
double this, I get 136. I get 12.
12.
Yeah, 12. So I have 68 and 12. So this went here. This was the remainder. So the next time, if it doesn't work, 12 is going to go there and then the remainder. 68 mod 12. Does that work? Nope. So now the 12's coming over here. 68 divided by 12, what's its remainder?
8,
8, good.
8,
Yeah, 8. Does 12 divided by 8 not equal to 0? The 8 comes over. What's the remainder of 12 mod 8?
4,
4. Good, Mohan.
4.
Does 8 divide evenly by 4? Yes. GCD is 4.
Yes.
Yes. That's better than going back to list all of the factors of 148, 1 and 2 and 72, all the factors of 68, circle all the common ones and find the greatest. Now this works much easier, especially once you have modulus down. Okay. Questions? 20-6 was the Fibonacci sequence. How it calls Fibonacci. Fibonacci comes in. I have my base case. If it equals that, I have my base case, it equals that. Otherwise, I'm going to return the previous number plus 2 numbers before. So if I wanted f of 3, remember that it becomes f of 2 plus f of 1, and so on. But when n equals 0, it returns 0. So this Fibonacci sequence starts at 0 and 1. A lot of other Fibonacci sequences start at 1 and 1. Did you miss me?
Yes, we did.
Yeah, my Wi-Fi or my internet dropped for a second. Okay, so what we're going to do is I'm going to put you in small groups. I have 2 problems I want you to write, 2 programs I want you to write using recursive functions. The first one is going to be the simple one that we used at the start of the class. So you're going to have an if else going on in there because we had 3 different possibilities. 1 base case, 2 recursives, or 2 recursive cases. Then I want you to try to create another one that when the user enters a number like 6, it's going to add up 1 to 6. And for those of you that are really good with pre-count, you know there's already a formula to do that, so we wouldn't need it, but that's what I want you to practice. For example, if I said, does anybody know n times n plus 1 over 2? So if I said, add up the numbers from 1 to 50, what do you get? Well, there's this formula. It's 50 times 51 over 2, or 25 times 51 would give you the answer. Guess we didn't know that formula. Anyhow, what I want you to do is to write these 2 programs. Good, Nathan, 1275. Nathan asked his phone. Or did you do it in your head?
I used a calculator.
Oh, okay. All right. So everybody understands what I want you to do. I want you to write a program to do this. Then I want you to write another program to sum up the first n numbers, depending on what the user inputs. Questions?
Professor,
Quiet today.
Professor, I have a issue actually. Probably I'm using the old version, old edition of the book, and chapter 20 is the binary
Right.
search operation.
The old version of the book probably has recursion in chapter 19.
Yes, and then I submitted my code listing from that
Okay.
binary search tree operation.
All right. You can email them to me.
All right.
Okay. Give me a minute. Yeah. So same thing, Logan. Send them to me. All right, I need to close all my rooms here.
So, may not be possible to send again today.
Email them to me. Just email
Alright.
them.
Yeah, I
Uh,
already did mine. I just kind of did chapter 19 because I saw that was recursions. So it ended up being the same.
Okay, good. All right, recreate. What's going on here? There we go. Okay, I'm going to open rooms. I'll be around. Call me if you have questions. Okay? Dario, are you going to your room?
Sorry, Professor.
That's okay.
functions.
Yeah, then F. And then times.
I prefer to see that one.
Now, remember, when you're calling a function, you're going to be calling f of a number. So I don't know, whatever that f of f is what you're calling it, right? So in line 24, you're going to be calling f of f of 2 times f.
Oh, okay.
Oh, okay.
Okay,
So calling f of f.
of parentheses. Now you were right, f of f.
No,
up front.
F O F parentheses, 2
Yeah,
times F,
Hold on, f of f times
2.
2. What was the formula? 2.
2 times F,
so put a 2 times out in front. Okay, now, first of all, before the 2, remember, we're going to be returning this value once it's calculated. So it should be return space 2 times f of, now in the parentheses, it should be, what are you doing? You're subtracting 1 from that f, so f minus 1,
F minus 1.
yeah. And then finally, you're putting
Another call.
you're putting a
It's a
plus.
+3.
Plus 3. Yeah, that's right.
Or would the +3 go out? Yeah,
Outside the
There you go.
parentheses, yeah.
Mhm.
yeah.
Good.
Alright.
Now, up in line 20, shouldn't that be a return of f times f plus 1?
Oh, yeah.
Because you're going to keep working your way back out. Now, if f is less than 3, takes care of everything less than 3, my line 22, could that just be f less than 5? 22, in line 22,
Yes.
yeah. So try to keep it cleaner that way. Yeah, and then finally an else, one more else. All right, I think that'll help straighten you guys out. Good.
Thank
Yep.
Thank you.
This seems not very hard.
It's not once you get the hang of it.
Hey, let me share my screen again because I think I accidentally shared just the window instead of the screen.
Recursive function X. Oh, you're doing them both in one program? What are you doing there?
Yeah, both of them in one program.
Oh, okay. Hey, you got the 53, right? You got the other one. Yeah, some people were having a little trouble with remembering to put the return in and how some different things were going, but yeah, that's all I really needed you to do today. It's one of those,
Yeah.
it's a wall until you get it, and then it's like, oh, I got it now.
Yeah, I learned recursive functions a long time ago, so this isn't really much of a problem for me.
Right, and Julie knows it well from CPS 230.
230 makes this easy when before, I guess it could be kind of confusing.
Right, right. Yeah, when you're done, we're done.
All
Easy
right.
day, easy day. All right.
All right.
All right, so
How we making
yeah,
out?
that's an if else. Okay, could you go over the first one
Yep.
again?
Yep. Do you need to see it?
Oh yeah, sure.
If you're on gallery view, you can see it. You see my little screen?
Yeah, I see it.
Okay. So what do you have as far as code so far?
We haven't started. We were looking
Okay.
basically at algorithm.
So what you're going to end up with here is, you want to stop sharing and I can share my screen?
Yeah.
Okay. So what you're going to, oh, I should stop recording.